topic that I want to cover is scientific notation. It's something that you should be familiar with from your math class, but I want to go back over it to make sure that you know what scientific notation is. Now, I will explain why we use scientific notation later, why it's called scientific notation, but first I just want to show you what it is. When we have a number, we can write it out with each number in its correct place value. We call this standard form. Sometimes, though, we like to shorten the number, particularly if it's a really long number, really big number, or a really small number. And the way we do that is we only write down the significant digits. We put one of those numbers in front of the decimal place and the other number after the decimal place. So these zeros at the end, these trailing zeros, they are not significant because there's not a decimal. So we're going to write this down with one number in front of the decimal place and the other significant digits after the decimal place, so 8.5. However, we want these two things to be equal. So to make this equal, we need to make it bigger. And we need to make it bigger by 1, 2, 3, 4, 5, 6, 7 place values. The way we can make it bigger by 7 place values is by multiplying it by powers of 10. In fact, we can multiply this by 10 7 times. So we can multiply this by 10 to the 7. So if we have a number, we take the first significant digit and write it in front of the decimal. We take any other significant digits, write them after the decimal, and then we multiply by an appropriate power of 10 to make this equal to what we started with. Let's look at another example. So here, our first significant digit is 9. First significant figure is 9. The other significant figures are 3 and 5. Now up here I actually counted over one at a time. You can do that. One of the nice things about the commas, though, is they can speed up your counting. So here I have 3 place values. 3 more is 6. 3 more is 9. And then I have to go 2 more, so 10, 11. So this is 9.35 times 10 to the 11. Now, we can do that for numbers that are bigger than the ones place, but we can also do it for numbers that are smaller than the ones place. So let's do 2 examples of that as well. Leading zeros are never significant. They're simply placeholders. So our first significant digit is 2. We put a decimal and we put all of the other significant digits after. Now, again, we want to make these equal. To make this equal to that, we need to make this number smaller. We can make it smaller by place values by dividing by 10. So we can divide by 10 1, 2, 3 times. Now, the way we write that is we write 10 to the negative third. Just want to remind you of something that you learned in math about exponents. A negative exponent means 1 over the same thing to a positive exponent. So 10 to the negative third really means 1 over 10 to the third, which means that you are dividing by 10 3 times. If we divide by 10 3 times, we get 2 zeros in front of the 2, 0.00271. Let's do one more example. So here, our first significant digit is 3. The leading zeros are not significant. The other significant digits are 4 and 8. To change this back to 0.0000348, we have to move the decimal 1, 2, 3, 4, 5, 6 times, which means we need to divide by 10 6 times, which means we need to multiply by 10 to the negative 6. So we can change big numbers into scientific notation. We can change small numbers into scientific